Hi there. What I want to explain is this is the equipment that we're going to use to measure the height of Tryfan, GPS, surveying grade GPS equipment. And we're using this because this is the equipment where we can measure absolute height. We don't need any reference points. So with that, how this works, I'll hand you over to my colleague Graham, who will explain.
Yeah, thanks John. Hi. As John said, this is the equipment that we're going to use. I'll just briefly take you through the different parts of it. The little mushroom on the top is the antenna that receives the signal. Beneath that we have a keypad from which you can control the instrument, and then down below you can see the processing unit that collects all the data that the instrument collects from the sky. Now, just to go into a little bit of detail now on how the equipment performs. And it performs in very much the same way as the sat-nav in your car, or perhaps the little handheld units that you take out onto the hills with you. Above our heads there is a constellation of satellites, and there's about 24 that are active and they are emitting radio waves, and those radio waves are picked up by the antenna in the equipment. One thing that differentiates the equipment we have here from the handheld unit, other than its size and apparent complexity, is the fact that it can pick up two different frequencies from those satellites, whereas your handheld unit will pick up radio waves just at the one frequency. So that gives us a little bit more accuracy in the measurement, but by no means enough accuracy that is required to make the measurements that we are proposing to make. In order to do that, we use the equipment in a different mode, and that is a differential mode. What do I mean by that? Well, what I mean is that we can link this equipment either directly or indirectly to a network of ground stations that are operated by Ordnance Survey in the UK. To illustrate that, let us just look over there at a ground station that we've set up for the purposes of this demonstration. So we have our equipment over here that is remote from a ground station by several kilometres probably, and over there we have a ground station operated by Ordnance Survey. I will now hand over to John, who will explain in detail how that helps us achieve the accuracies that this equipment can obtain.
Hello. So what we have is a mock-up here of an Ordnance Survey ground station. Basically it's very similar to the equipment we've already, it's a GPS setup at a known point. And the Ordnance Survey have measured very accurately over thousands of measurements the exact position of this point. So what is happening, as our data is being collected in the GPS at the point we're measuring, data is also being collected at the reference points. So let's take an example. Suppose at 12 o'clock the reading on this GPS is 202 metres. And we know from the Ordnance Survey, know from their measurements that actually it's 200 metres the exact height. We know that it's over reading by 2 metres. Therefore, we can apply that correction at 12 o'clock to the reading that we're taking. And so you can keep on doing this. These corrections are available from the internet or in real time, and they allow you to bring the accuracy of the measurement down to the order of centimetres rather than metres as it was before.
Well, cheers John, and also cheers Graham. A fascinating insight to the working of differential GPS. So here's the dummy base station that they set up. I don't think the antenna is very stable on top, is it, John?
It's nice to eat out.
So there we are, and we're in John's back garden. And if I just come back over to Graham. Now, obviously, Graham, there's for Tryfan, because the next clip that we're going to show the viewers, we're going to do a dummy setup somewhere that hopefully next to a standing stone circle.
Yeah.
And what you've got here, you've got a pole at a 1 metre length, haven't you?
Well, that's right, yes. I mean, I should add that that's set up for the purposes of this demonstration. You can set it up on a 2 metre pole or a 3 metre pole. We have an extendable pole as well, so we have quite a lot of flexibility what height we set the antenna. And of course, in real life, I wouldn't be standing next to it like this if it was operating, because I'd be interfering with the signal. So you do need to bear things like that in mind.
Well, many thanks for your time, and to explain to the viewers how the differential GPS works. A fascinating insight into the realms of science. So cheers, John and Graham. Thank you.
Cheers,